Welcome to another edition of Comet Algebra. This video is for Algebra 1, Chapter 5, Section 3, Graphs of Relations and Functions. This section is a continuation of what we learned yesterday when we said that each x can only have one y. And we did that with lists of relations when they were given to you in ordered pairs. Today we're going to look at the graphs of those relations and see if we can tell if it's a function or not by looking at the graphs. So first, a definition of the vertical line test. If any vertical line intersects the graph at only one point, then we would say yes, it's a function. So just to remind you, vertical means up and down. So we're going to be drawing vertical lines in, and another way to say this is if the line hits the graph twice, then no, it's not a function. So let's look at the first example here. So we picture ourselves, and you can do this mentally. I'm just going to write it on this graph. We're drawing vertical lines in here. And so far, okay, right here we hit one point on the graph. So far, so good. But we have a problem when we come right here. We're going to hit that point and hit that point. And since we just hit 2 points, we'd have to say, no, this is not a function. And this corresponds with what you learned yesterday, because this x right here, this x of 1, has 2 y's. It has a y right here of positive 1 and a y right here of negative 1. And if each x can only have one y and this x has 2 y's, it's not a function. Let's look at the second example here. Once again, we're drawing vertical lines. We're fine, we're even fine over here. But we run into a problem if we draw a line that passes through that point and that point. These are both solid and filled in. That means these are both part of the graph. Because this one vertical line hit the graph twice, then no, it is not a function because this x has 2 y's. Next example is a sideways parabola. And right away we see we draw a vertical line, it hits it twice, so no, that's not a function. If we had a parabola that was like this, that was right side up, and then we started drawing vertical lines, this one would be okay. This type of parabola would be a yes, that is a function. All right, down here we have, this is an x cubed function. So it comes up and it curves down, then it curves and goes back up. So we're picturing ourselves drawing vertical lines here. And this looks okay. No matter where I'm drawing a vertical line, even if this graph goes on forever and ever in that direction, this is a function because my vertical lines are only hitting it once. A circle, you can see pretty quickly that is not a function. I would say no. All right, in this next part, we are asked to state the domain and range and determine if it is a function. So before we do this, I just wanted to have a little bit of a reading lesson so we would know how to state domain and range. So on this screen right here, the reading lesson is this line, this up and down line that sort of looks like half of an absolute value symbol. This line means such that. So let's just read this. I'll read this to you. This capital D means the domain is, and this bracket means set notation. So domain is the set of all x such that x is in between 0 and 3 and includes 0 and 3. The x is in between them, meaning the lower limit of the domain is 0 and the upper limit is 3. So let's try that again. Let's read this. I'll read this to you. R stands for range. The range is the set of all y's such that y is in between 6 and 20. 6 is the lower limit of the range. 20 is the upper limit of the range. So what I wanted you to get out of this is how to write domain and range and how to read it. So let's practice using that notation to write the domain and range of these particular graphs. So this first one, we have an upside down parabola and we are asked to find the domain. So I'll put D equals Now it is going to be the set of all x such that, well, let's look at it. Domain. We remember from our discussion in the last section, domain is the x values. So your eyes should be looking back and forth this way on this graph, looking for what the x is, if there's any limits, if there's any place it does not exist. So if your eye goes this way and we see that the graph is decreasing and getting a little bigger, this could go out to negative 5 million, trillion, whatever, and we're fine. The graph exists there. If we went off this direction in the positive direction and the graph just keeps getting bigger and bigger, again, no limits on the domain. So this one, I don't need a range of limits because the domain is everything. It's capital, that funny R. This is all real numbers. So that's kind of nice when it works out that way. Now we have to do a total shift. Your eyeballs have to change for finding the range now, the range of this graph. Now I want your eyeballs to go up and down this way, looking up and down. And then you're asking yourself, where does this graph exist? Well, I'm coming here. Does this graph exist up here at positive 5? And the answer is no, because there's no graph here. And as we go to 4, 3, 2, 1, right here at 0, that's where it starts existing. So our range is going to have some limits. So the range is the set of all y's such that if it starts existing at 0 and it exists all the way down to negative infinity, we could say that y is less than or equal to 0. There is no lower limit. It just keeps going down. So now we have stated the domain and range. We need to determine if it is a function, and any vertical line I can draw is only going to cross once, so we'll say yes, it's a function. Let's look at this next example. Now this is a graph made out of dots. This isn't going to be, the domain isn't between two numbers. This time, domain is a list. So your eyes are going this way. You're looking at x's and figuring out which x's where this graph exists. So right here, does this graph exist over here at negative 3? And no, it doesn't. But it exists right here at negative 2. So that is an element in the domain. Right here at negative 1, the graph also exists. Checking right here at 0, there's no dots there, so there is no 0. Checking 1 here, nope. Checking 2, again, no dots. But right here at 3, we have a dot. So we just have 3 elements in our domain. Now let's look at range, where your eye shifts, and now we're looking up and down the y-axis. So it doesn't matter if you start at the top or bottom. Let's see. Does this graph exist down here at negative 3? No, it doesn't. Does it exist at negative 2? Yes, there's a dot right there. Does it exist at negative 1? Nope. Does it exist at y is 0? Yep, there's actually a couple dots there, so 0 is in the range. It does not exist at 1, but it exists here again at 2. So we just have a couple lists like that for our domain and for our range. Now, is this a function? Well, we can see right here. If we draw a vertical line that hits it twice, we'd have to say no, not a function. All right, this next example, again, we're asked to find domain and range. Well, this time we can see that the domain is going to be existing between here and here. And it's solid, it's continuous. So the lower limit of this domain is right here at negative 2. So the domain is the set of all x such that negative 2, there's my lower bound, less than or equal to x, less than or equal to, now we got to search for the upper bound. So here's negative 2, there's 0, there's 1, there's 2. It goes all the way up here to positive 3. Now shift your eyes up and down. We're looking up and down this way for the range. It starts existing right down here at -3, and you got to see how far up it goes, where it exists. So the range is the set of all y's such that down here at -3 is the lower limit where the y's start existing. So we're fine at -2, it exists at -1, it exists at 0, and 1 right here, that is the upper limit of this range. Is this a function? Well, it's looking pretty good. You might question right here if we draw a line. Well, the open circle means it's not included in the graph, if you remember your days from graphing on number lines. But the closed circle it is, and so it passes the vertical line test. So we will say yes, it is a function. Our last example down here, this is an x cubed graph, and I don't know if it's clear. Let's see, this goes up here to 4, down here to -4. This is over to 3, and this is over to -3. Sort of hard to show you without graph paper, so that's why I put the numbers in. So again, we need to state the domain and range of this graph, and we need to decide if it's a function. Since this has lines and it's in between our domain, we're looking at the x-axis for the domain. The domain, there's the lower limit and there's the upper limit. So the lower limit domain is the set of all x such that -3 is less than or equal to x is less than or equal to 3. And then the range is the set of all y's such that, okay, switch your mind and start going up and down the y-axis. It starts right down here at -4 is the lower limit of the range. So -4 is less than or equal to y is less than or equal to, and the upper limit of the range is up here at 4. And then if we draw in any vertical line, it's only going to hit this graph once, so we would say yes, it is a function. So now I believe you have all the knowledge you need to do section 5.3, so have fun with math.